Welcome to today's session on solid principles. In this part, we will focus on two important principles, the Liskov substitution principle and the interface segregation principle. Let's dive into these concepts and see how they impact object-oriented design. Today's session will cover an overview of the two principles, Liskov substitution and interface segregation. We will explore the definitions, key points, examples, and code demonstrations to help solidify our understanding. The Liskov substitution principle or LSP is a core concept in object-oriented design. It states that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. Let's explore what this means in practice. LSP ensures that derived classes extend the functionality of the base class without altering its behavior. It promotes the safe use of inheritance in object-oriented design. Violating this principle can lead to unexpected behavior and bugs in our code. Key points to remember about LSP. First, derived classes should not change the behavior of the base class. Second, LSP allows for the safe extension of functionality. Finally, violating LSP can result in bugs, which is why it's essential to follow this principle. Let's look at an example where LSP is violated. Consider a rectangle class with a square subclass. The issue here is that square alters the inherited behavior of the rectangle class, which leads to unexpected behavior. Here's the code that demonstrates the violation. The square class inherits from rectangle but changes the behavior of the setWidth method, which results in incorrect behavior when the object is used in the same way as a rectangle. The correct approach is to avoid inheriting from rectangle altogether. Instead, separate the rectangle and square into distinct classes, each with its own specific behavior. Here is the corrected code. By making rectangle and square separate classes, we ensure that we don't violate the Liskov substitution principle and avoid altering inherited behavior. Moving on to the integration segregation principle or ISP. ISP states that clients should not be forced to depend on interfaces they do not use. This principle promotes the use of smaller, more specific interfaces rather than larger general ones. To follow ISP, create multiple small interfaces instead of a large one. This avoids unnecessary dependencies and ensures that clients only depend on the methods they need. Key points to remember about ISP. First, clients should not be burdened with unnecessary methods. Second, small role-specific interfaces are preferred over large generalized ones. Finally, ISP improves code modularity and reduces unnecessary dependencies. Now let's look at an example of an ISP violation. Consider a large printer interface that forces all classes implementing it to implement unnecessary methods like scan and fax, even if they only need to print. This code demonstrates the violation. The printer interface forces a class to implement methods it may not need, leading to unnecessary dependencies. This violates the interface segregation principle. To fix this, we can split the printer interface into smaller, more specific interfaces. For example, create separate printable, scannable, and faxable interfaces each defining a single method. Here's how we can apply the correct approach to ISP. By separating the interfaces, we ensure that clients depend only on the methods they need, reducing unnecessary dependencies. For a practical exercise on LSP, we will create a shape class with a getArea method that can be extended by a circle and class triangle classes. The goal is to ensure that substituting a base class object with a derived class object does not cause any issues. For ISP, let's design a system where we split the machine interface into smaller, more specific interfaces like coffee maker, juice maker, and tea maker. This way, classes can implement only the interfaces they actually need. Let's recap the key benefits of LSP. The Liskov substitution principle ensures that derived classes can safely substitute base classes objects without breaking functionality. This promotes stable and predictable behavior in object-oriented systems. Similarly, the interface segregation principle reduces unnecessary dependencies, improves modularity, and ensures that classes only implement the methods they actually need. Both principles lead to cleaner, more maintainable code. To wrap up, remember that LSP allows safe substitution of base class objects, while ISP encourages smaller, more specific interfaces. Both principles play a crucial role in creating robust and maintainable software. Thank you for your attention. Now, let's open the floor for any questions or discussions. Feel free to ask about any concepts or examples we have covered today.